Hi there. Hope you're doing well. My name is Vadiraj Joshi. Today I'm going to demonstrate about my capstone project for IBM Coursera, and I've chosen to work on a stock prediction. I have prepared a small presentation to give a walkthrough about this project, and here's the agenda. The use case selected and the data set for the same, exploratory data analysis, data cleansing and wrangling, model definition and training, last, model evaluation and tuning. Let's dive into the use case. I've chosen the stock predictor, and it will make a market predictions based on the stock data of Dow Jones specific to this use case and the news headlines for the past 8 years. As we all know, stock market plays a very important role in a modern economic and a social life. Investors always look for ways to increase value of their assets by investing in the stock of the listed company with high earnings. In the past years, researchers mainly constructed statistical models to describe the time series of a stock price and the trading volume to forecast the trends and future stock returns. It is worth noting that the intelligent computing methods represented by ML algorithms today also present a vigorous development in stock market. And with the various data sources that we have, such as multi-source heterogeneous financial data, high frequency trading data, rich and diverse technical indicators data, macroeconomic data, policies and regulations from different countries and agencies, market news which is specific to this use case again, and social network data. So these are sometimes termed as alternative data or the alpha data, which are the key differentiators. And who are the potential clients who use this stock predictor? Would be specifically to Dow Jones, of course, but also it can be extended to different companies listed on Nasdaq. Further, the stock predictor can be used by brokers and financial advisors who work at wealth management companies to recommend and suggest the stocks for their investors. Let's get into the data understanding part. So I have selected a daily news for a stock market prediction data set from Kaggle, and it is a very interesting data set to work with. It comprises of news data which is crawled from a Reddit World News channel and the stock data from Dow Jones Industrial Average. The next part is data cleansing. I would like to thank the person who was contributed to Kaggle dataset, and it is relatively clean and there are no much outliers. The one thing that I learned from this dataset is each row in the headlines dataset was iterated over an algorithm which generated the subjectivity, objectivity, positive, negative and neutral sentiments, and it was for every single sentence. So what the one thing that I brought in a change is I modified the algorithm to iterate over all of the individual rows so that simultaneously it can create all the sentiments and assign a value to itself and concatenate the data frame from headlines 1 through 25, the top headlines, and then pass it to the algorithm. So the newly merged concatenated data frame was sent to the algorithm, and as you can see in the bottom right corner, most of the features are normally distributed and there is no much data skewness. And this is my exploratory data analysis part. As you can see, the subjectivity and objectivity versus stock price is normally distributed, and the correlation matrix obviously reveals the features that are highly or closely correlated. So let's get into the model definition. Now that we have a good insight into the data, we can now dive into the model definition. But before I do that, I would like to show the notebook that I have created, and it's available on the Watson Studio, and the URL is on the my profile. So this is a stock market prediction, as I mentioned, the two data sets, And these are the data sets that I'm using in this notebook: the combined news, Dow Jones data, and the combined stock data. And the steps taken are explained here, and I have used IBM data science methodology by John Rollins to accomplish this, which is an iterative process. And as we begin, we import all the libraries, necessary libraries, and this is the section about the data assessment part. 1.2 talks about EDA, the steps taken for exploratory data analysis. This is the data frame that it looks like from a combined stock data. Further moving on, this is the merged data frame that I was talking about in my slide. The section 1.3 talks about data quality for each of the features. And this is my EDA in terms of how the data is distributed, the data skewness, and each plot explains about the different plots. Moving on, the section 3 talks about the feature engineering, and there are only 7 outliers from this chart, and this is the correlation matrix I was talking about in my EDA slide. And fourth is the training part. So as I can I think on my slide I stopped here. So I considered some of these algorithms, classification algorithms, logistic regression, linear discriminant analysis, which is LDA, the k nearest neighbors, decision trees, naive Bayes, support vector classifiers, random forest classifiers. So I defined them as a part of the list, which is models, and then I calculated a score for each model, and this was a score for each of them. And as you can see, the LDA scores high. Yeah, here's the logistic regression, which is 53, and KNN is 45, 54, 53, 53, 56, and 58. But one thing that we can notice as a machine learning engineer is LDA definitely scores high, but looks something fishy. So I tried to plot a confusion matrix for this along with the classification report, and that also came neat. And this one is for XG boost, I guess. Yeah, that is for the XGB classifier. So I try to plot a ROC curve to check whether model is performing well, and the ROC curve score is poor. So I didn't take the LDA path, so I took a detour and focused on random forest classifier, and I did some feature importance along with the principal component analysis, that is the PCA part. And this is the plot for feature extraction, the feature engineering part, to see which are the features that are highly important that can be fed into the algorithm. Further down, you can see I've used XGB classifier with PCA, and these are the hyperparameters along with the max depth of 12, and these are the estimators up till 1000. And when I iterate that model for a training of with those parameters and along with the PCA, which is used to reduce the dimensions of the data, and that came in handy. With that, the model score was pretty nice, 94%. And as we did in LDA, I also did a confusion matrix along with the classification report, which is pretty good, and also the ROC curve, which is showing 98%. That means we can conclude the model is performing well. That this suggests that our model is performing good at an accuracy of 94%. And quickly moving on to my slide, this was a model definition part. I think I already covered this in my notebook. The training part, yeah, one thing I forgot to mention is in time series data, the chronology is an important part. So I used a train test split for this, and when you're doing a split, you need to make sure the chronology is maintained. And I used 70% of this data for training, and rest 30% was used for testing. So this is the result part, and as we already saw the evaluation part, I think we concluded that LDA shows 94%, but ROC curve was not promising. And this is the feature engineering part, which we already saw, and the tuning part, where we concluded the XGB classifier, and the conclusion is we are going with XGB classifier where the ROC curve is 98%. So that's it about the presentation. And in terms of the notebook, the next parts would be definitely try out ARIMA model, and also give a try at Profit from Facebook, which is good for a time series data, and make this as an API, REST API with a Flask web framework, integrate it with any client facing applications such as wealth management apps, and also it can be integrated with bots such as Watson Assist from IBM, and further it can be integrated with existing portfolios for any stock recommendations. And here's my quick high level architecture. As I was mentioning, an end user logs into the stock predictor tool, definitely through Identity Access Manager, which is IAM popularly known as, and once the entitlements are authorized, he logs into the system. And as I envisioned that the stock predictor can be integrated with a conversational AI chatbot such as Watson Assist from IBM. The user can ask direct natural language questions such as predict stocks, and what's the impact on my portfolio due to any announcements or market news, and top stocks to pick based on my portfolio. And there's a UI manager which does a lot of handshaking between the front end and back end, and there is actionable insights component and a real-time processing engine which collates all the market data. The right side, as you see, it's an enterprise apps. Specific to this use case is Dow Jones Industrial Average data with all the DMAT and assets for each profile. And this is the enterprise data, and this is the transformation and connectivity which is integrated, and this is the integrated database. And there is a social data definitely with the third-party APIs which comes from the social database in the public domain. And both of these are integrated into the material master data, which feeds to the analytics and machine learning layer, where all our highly trained machine learning algorithms are working on the data. And based on that data, the Watson Assist gets all this process data which can be presented to the end user through the UI manager. So that's all about it, and thanks for listening. Any feedback, please let me know. Thanks for hearing me out, and always stay curious.